Okay, here we go. Linear functions, video number 2. Let's take a look at our next problem here. So it says, analyze a linear function. It says, Tamika records the outside temperature at 6 a.m. What is she doing up that early, huh? The temperature increases by 2 degrees every hour for the next 6 hours. If the temperature continues to increase at the same rate, what will the temperature be at 2 o'clock p.m.? So this idea here of increasing by 2 degrees Fahrenheit every hour, that is your rate, that is your slope. Your m value is 2 degrees Fahrenheit per hour. Okay? So then the idea is, okay, what's going to happen at 2 p.m. if it keeps increasing at the same rate? Well, I'm going to draw a graph real fast. Okay, we're going to put temperature on our y, temperature in degrees Fahrenheit. And I'm going to put on our x value, this is going to be, and this is kind of tricky, this is going to be hours after 6 a.m. Okay, so because she started recording the temperature at 6 a.m., this is again going to be hours after 6 a.m. Okay, so the reason I have this y-axis a little bit longer is because there's going to be some negative temperatures involved. As you can see here, right? So when x is 0, which means when it is 6 a.m., the temperature was negative 3 degrees. That's right here. If we count by ones. I think I have to count by 2s here just to make sure it fits. So we're going to let every one of these be 2. So that's 4, 6, 8, 10, 12, 14, 16, 18. So it stops at 18. Okay, and then down here this would be negative 2, negative 4. So at 6 a.m. it's 3 degrees Fahrenheit. Every hour it increases by 2 degrees Fahrenheit. So again, I'm going to count by ones on the x-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for every it increases 2 degrees Fahrenheit, so from negative 3 to negative 1, got to skip. So 1, 2, and then over 1. 1, 2, over 1. Notice I'm counting like half spaces. 1, 2, I'm sorry, that should not be a point. 1, 2, over 1. And this is going to give me a pretty accurate graph if I were to draw a line like so. As best I can. There we go. So we can use this linear picture to find or estimate what the temperature is going to be at 2 p.m. Now we have to think about it. How many hours after 6 a.m. is 2 p.m.? Well, it takes 6 hours to get from 6 a.m. to noon, and then 2 more hours to get to 2 p.m. So this is going to be 8 hours after 6 a.m. So 1, 2, 3, 4, 5, 6, 7, 8. At 8 hours, we are right around here. That point, I'll do it in blue. So 8 hours if you go up this point. So if we go over to our y-axis, we are right here in between 12 and 14. So it looks like it's about 13. So we're estimating that at 2 p.m., 8 hours after 6 a.m., we are going to be at 13 degrees Fahrenheit, right? So I think this is the point 813. Well, let's verify by creating an equation and plugging in our x value, right? So we're going to create our equation. F of x equals mx plus b. Again, it's just y equals mx plus b, but we replaced f of x with y. We know our slope. Our slope is 2. We know our b. This was the initial temperature. Our b is negative 3, the y-intercept. So our function f of x equals 2x minus 3. So now we're letting our x value be 8. 8 hours after 6 a.m. So plug in 8 for x. Plug in 8 for x. And simplify. 2 times 8 is 16. Minus 3 is 13. And that's how we can get 13 degrees Fahrenheit at 2 p.m. Okay? So again, this down here was the important part, building the function. We just want to kind of give you an idea of a visual representation of this function as well. All right, part B. It says, does using a linear function realistically represent the temperature for the domain 0 less than x less than 24? Explain. So this idea of domain and 0 less than x less than 24. So what this is 24 because there are 24 hours in a day. So 24 hours in a day. So the question is, should we continue to use this linear function that keeps increasing from 0, which would be what, 12 a.m. to, the end of the day, which would be like 11:59 p.m. late at night? Well, the answer is no. Right? Think about how temperature works. Does temperature constantly go up? When you look at your, Apple temperature, or you look at the Weather Channel app, is it always going up all day long? No. Typically, you start cooler in the morning, you kind of peak in the afternoon, and then you come back down towards the evening. So this linear function would not realistically represent. So we're going to say no. And we're going to say throughout a day, the temperature, I'm going to abbreviate temperature, TEMP, the temperature usually increases in the morning hours, stays the same in the afternoon, so it levels out, right? Stays the same in the afternoon, and then decreases, in the evening and overnight. So this is trying to get you guys to think through, like, in real life, would it make sense? So we're not going to use this graph. That would just increase the entire time. We're not going to use that, right? We're going to use this graph, which it would start low, it would increase, stay the same, and then go back down. That would be the graph we would use to represent how the temperature fluctuates as the day goes by. Okay, I've got one more word problem here. Again, they're very important. It's a great way to represent things using functions. So it says a chairlift starts 0.5 miles above the base of a mountain and travels up the mountain at a constant speed. How far from the base of the mountain is the chairlift after 10 minutes? So if you take a look here, right? This is where it starts. It starts 0.5 miles from the base. Notice on your graph where the y-intercept is. The y-intercept is right there at around 0.5. So this right there is your y-intercept, 0.5. Now, it says constant speed. Constant speed is slope, right? Miles per hour. So notice here, it gives you the chairlift travels 6 miles per hour. That is your slope. Your slope is 6 miles per hour. And we want to know how far will it be in 10 minutes. So we have one big issue here. And the big issue is that our units don't match up, right? So I'm going to change our slope from 6 miles per hour into miles per minute. So to do that, we're going to take our slope. It's 6 miles per 1 hour. And I'm going to say, okay, right? How many hours are there, or how many minutes are there in an hour? Well, over here, 1 hour is 60 minutes. So I'm going to replace this 1 hour with 60 minutes. 6 miles in 60 minutes. And if I were to divide that, you get 0.1 miles per minute. This is my new slope. And now I want to build my function in slope-intercept form with my slope and my y-intercept, 0.5, my b-value. So again, f of x equals mx plus b. I have my slope, so f of x equals 0.1x, and my b-value is 0.5. And now my x is time in minutes. So now this 10 minutes, this is your x value. Plug it in. F of 10 equals 0.1 times 10 plus 0.5. And you simply simplify that. Simply simplify. And you get 1.5. And that means that after 10 minutes, you would be 1.5 miles 1.5 miles above the base of the mountain. And you can see, again, I think I copied and pasted this graph from the textbook, that after 10 minutes, you're 1.5 miles above the mountain. Great. Okay, so hopefully we get used to this, function notation and bring our knowledge of linear equations into this section. All right, so thanks for watching. Good luck on your practice.